Hi students, it is Mrs. Bogus. I'm coming to you live from my classroom. I am sorry to miss you today, but hopefully this is a nice little break for you as we start our next unit. So before I continue on, I want you to know, hold on, I can't get my screen to go. Okay, you should go to your home schools and get one of these note packets. The notes I'm going to go through today correspond with the first page in here. If you don't have it, that's fine. If that's not where it's at for you, cool. But I will be referencing this a lot over the next few weeks. These packets are at your home school. You can ask the office manager in the main office for one, or they should know where they are, or they're in the front foyer at Roosevelt. So come get it. I wrote on mine what the unit is. It's Unit 6, and we will be using these over the next few weeks. So just a little roadmap of where we've been and where we are going again. So in chapter 2, which was our first topic, we talked about the normal distribution. We did that again in our last unit. In chapter 4, we talked about randomly selecting using samples and experiments. And then in our chapter 7, which was what we just finished, sorry, there's like topics, chapters, units, we learned that different samples yield different results for an estimate. And then we also talked about probability and being able to come up with conclusions. So we're going to put all of this together over the next, really for the rest of this class. In this unit and in our next 2 units, we will be talking about statistical inference so that we are able to take a sample and make conclusions and claims about populations from our sample. So we're using statistics to make claims about parameters. And this is a fun little comic. Gotta love Garfield. So up first, we're going to talk about what exactly is a confidence interval. This unit is going to be all about proportions, and we're going to talk about confidence intervals and then significance tests. After that, sorry, we will do means, and then after spring break, we will talk about what happens when we have categorical data. So a confidence interval is a set of plausible values for a parameter. We interpret a confidence interval by saying we are some percent confident that the interval from, and then we'll have 2 numbers, captures the true, and then there's a parameter in context. And the confidence interval, those 2 values, and then the parameter is what we will be working through. At any time, excuse me, feel free to pause this and so you can copy things down. I've also uploaded the PowerPoint to Canvas. So why would we be interested in a confidence interval? As we've talked about, it is very challenging to get an exact number for a population. Unless we survey every person we could possibly want to know about, we would not be able to find what the true parameter is. So we might be interested in knowing what proportion of US adults are unemployed, maybe how many people have received or plan on receiving the COVID-19 vaccine, what proportion of high school students maybe have cheated on a test, hopefully 0, and then what proportion maybe of a company's laptop batteries actually do last as long as the company claims. So we would be able to find an interval instead of just finding one hard number, and we would make that interval with a specific level of confidence. Let's take a look at this example. 2 weeks before a presidential election, a polling organization asked a random sample of registered voters the following question. If the presidential election were held today, would you vote for candidate A or candidate B? Based on this poll, the 95% confidence interval for the population proportion who favor candidate A is 0.48 to 0.54. I want you to interpret what this interval means. Pause the video and unpause it when you're ready for the answer. So if I were to interpret this confidence interval, my interpretation, and I'm going to move myself up here hopefully, my interpretation would be that we are 95% confident, and that was given to you. It says a 95% confidence interval. So we are 95% confident that the interval from 0.48 to 0.54 captures the true proportion of all registered voters who favor candidate A in the election. So let's kind of take a look at this. If I'm looking at my confidence interval that's usually given to me, I get my actual interval from this value, and we're going to be creating and finding what those numbers mean on our own. Whoops, now you can't see that. Oops. And then the population proportion who favor candidate A, and it's the proportion who favor candidate A. That's what our parameter is. I want to include this. It's very important that a confidence interval does not necessarily mean the probability of something. So it's not a 95% probability. It just tells us with a certain amount of confidence where the parameter could be. Once we make that confidence interval, it is a fixed interval, and the probability that it does or does not capture the parameter is pretty black and white. Just kind of like I either am or am not going to win the lottery tomorrow. I either am or am not going to work out when I get home from school. It's one or the other. It either does or does not capture that actual true value. So we're not talking about a probability here. We're just talking about our confidence that it's within this interval. So the two components of a confidence interval are on the screen right now. We have a point estimate, and then we have what's called a margin of error. So our point estimate is always right in the middle of our interval. It's the median, if you will. And then we have a margin of error that allows us a certain amount of wiggle room based on some factors that we'll get into. The margin of error describes how far at most we would think that the estimate varies from the true value. So you might see a lot, like especially when it was the election, margin of errors when we're talking about polls, because there's always a chance that that's not the exact amount. So we're just given a specific bit of wiggle room. Two things that affect the margin of error. The margin of error is affected by the confidence level. So the more confident we are, the larger our margin of error would be. And our sample size. The larger our sample size, the smaller our margin of error is. So if we ask less people, right, if we ask less people, our margin of error goes down. And surprise, surprise, you might be thinking, Mrs. Bogus, didn't you just talk about increasing sample size and decreasing variability? Yes, I did. So we can see here on your screen that there is an interval for an 80% confidence interval and then a 95% confidence interval. So the wider the interval, the more confidence we have. Duh. So here are some examples, and I made this PowerPoint last year, so before we even knew who was going to be the Democratic nominee, let alone going to be the president. So we can see that these are two examples of where we see margin of error. So in the first one, we talk about Bernie Sanders being in the lead, followed by Pete Buttigieg, Amy Klobuchar, and then Biden and Warren, and we can see that the polls margin of error here was 4.4 percentage points. So sometimes when we see these margins of errors, you could have a certain margin of error or a certain proportion, and then the margin of error kind of makes something else true. So just things to keep in mind, trying to make you guys savvy citizens. So a more general formula for a confidence interval is going to be what you see here. We're going to have some statistic that we find from our sampling, and then we're going to add or subtract what that margin of error might be. And the margin of error, as you can see up here, is dependent on two things. It's dependent on our critical value, which helps make our interval, and it depends on our standard deviation. A critical value is some multiplier. It's always going to be a constant that makes our interval wide enough to have a specific stated confidence. So 95, we might be 99, we might be 90. We're usually never really less than 90% confident in something, at least not in statistics. To find these critical values, we are going to use the area under a normal curve. And like I said, these values are going to be constants, so they are always going to be specific numbers, specific values. So you're not going to have to guess or find these each time. You are going to be given what those numbers would be. So how do I want to say this? I'm just going to give you what the critical values are going to be. You don't need to find them, but they are related to the area under the normal curve. So an area from the middle, right, an area that gives us that 95%. Remember when we talked about the empirical rule during our first semester, we were at 1, 2, and 3 standard deviations for the mean, and a z-score of about 2 gave us an area within 95% of the mean. We're actually going to use a different critical value for a 95% confidence interval, and I'm going to write these on the screen in a very not great way because I just have my mouse right now. So the critical value for 90% is going to be 1.65. I would write this down. For 95%, it's going to be 1.96. And again, these are standard deviations. And for 99%, it's going to be 2.58. Wow, those are some really bad looking numbers. The official name for a confidence interval is actually a one sample z interval, and we're going to be talking about proportions. When the conditions are met, this is exactly what the formula is going to be, what we're going to be plugging in our values in. We're going to plug, we're going to find them out right away. A one sample z interval looks like this. I'm going to have you write it down, and a lot of these should look familiar. Okay, we have our p hat, which is our statistic or our sample statistic. And then this should look familiar as the standard deviation for the proportions. So there are 3 conditions that have to be met in order for us to be able to use a confidence interval, and you will need to show that all of these conditions are met. The first condition is that our sample comes from a random sample, and that's how we are able to use this p hat. That's the part. How we would know this is if it is stated in the problem. It's either going to be stated that it's a simple random sample or it will be given, like given a simple random sample. And we check this because when our data comes from a random sample, we can make an inference about the population. If I were to just ask all of you a certain question, I can't make that inference for all Des Moines Public High School students because you are my convenience sample. So we want to make sure we are taking a sample that is reflective of the general population. If it's not random, we can't do that. We need our conditions to, or our sample to be a normal distribution, and that allows us to use this z-score and to calculate and use the critical values. For proportions, we do this using the large counts condition, which we just got done talking about. And we, like I said, need this to be so that we can calculate whatever a critical value, whatever that will be. If we don't have a normal distribution, we can't use these critical values. And that's how we make confidence intervals. And then the last part is that we need to make sure that our proportion and our sample is independent so that the influence of one does not matter on others. And we do this by checking what's called the 10% condition, making sure that our sample size is less than 10% of the population. Why we do this is because it is nearly impossible to sample with replacement in this situation. So we need to make sure that things are independent. And in statistics, we can say things are independent if they are within or less than 10% of our entire population. Okay, so I just rushed through that. But you're welcome to visit this video at any time to fill out those notes. Don't worry about the choosing a sample size underneath. There's some practice on Canvas, and I'll see you tomorrow.